This recording is to help you with lesson 2.01 quadratic functions. And we're going to start by graphing the quadratic functions to find the vertex, intercepts, and zeros of the function. So when I graph it, I get a graph that looks like this. The vertex, remember, is your high or low point. So that vertex appears to be at -1, 4. The intercepts are where it crosses the x-axis and where it crosses the y-axis. So it looks to be that -3, 0 and 1, 0 are the x-intercepts, and these are what we also call the zeros. So where it crosses the x-axis is also known as the zeros of the function. Okay. And then we do have that extra intercept of 0, 3 where it crosses the y-axis. But that is not called a zero. That's just an intercept. All right, and now let's complete the square. So we take half of 2, which is 1, we square it, so we're adding 1. Because I'm pulling out the -3, there's a negative out front. So really that's like a +3 if I were to distribute that. And then I want to add 1. That's what I did on the inside. So I get -x plus 1 squared plus 4. So if I were to check my vertex, I would take the opposite h, so -1. K is 4. All right, next find an equation for the parabola. So let's just start out with my generic equation. Remember, h comma k is your vertex. So my vertex is 1, 0. So h equals 1 and k equals 0. So I can plug that in right away. And then I also have a point on my graph. And the point is x equals 0, y equals 1. So I can plug that in right away too. And when I plug that in, I can solve for a. So I do get something that looks like this. So 0 minus 1 is -1. -1 squared is a +1. So I just get 1 equals a. Now that I know that a equals 1, I can plug everything back into my equation. I get y equals 1 times x minus h is 1, and k is 0. So here would be my final answer. Next one, find the quadratic function that has the indicated vertex and whose graph passes through the given point. Okay, same type of thing here. So y equals a times x minus h squared plus k. That's your standard form there. I know that h is 3, k is 4 from my vertex. I know that x is 1 and y is 2. So when I plug all that in, I get an equation that looks like this. And now let's work on simplifying. So it looks like they subtracted 4 from each side to get the -2. Equals, and then if they simplified here, 1 minus 3 is -2, -2 squared is a +4. So if we divide each side by 4, I get a equals -1/2. So then I can come back and plug in a, so that's -1/2. H we know was 3, and k we said was 4. So that's how we can come up with that equation. Next one, use a graphing utility to graph the quadratic function. Find the x-intercepts. All right, so the x-intercepts are where it crosses the x-axis. So right here and right here. When we're using our trace feature, we should see that it's about -5/2, which is -2.5. Okay. 0, and then it's 6, 0 is our other x-intercept. Now we can factor this to find the zeros because the zeros are where it crosses the x-axis. So if we were to factor this, it would factor like so. Setting each parentheses equal to 0 gives me, I have to subtract 5, divide by 2, so negative 5/2, and then adding 6, which would just give me a positive 6. So that does match up to what our graph shows. Okay, last one, I have a model here with an equation. Notice that x has to be between 5 and 40, including those. So first we're just going to graph it, then we're going to estimate the number of board feet in a 16-foot long log, and then estimate the diameter, a scale of 500 board feet. Okay, so let's just start by graphing that equation, plug it into the graphing calculator, and you should get something that looks like this. Notice you will have to change your windows. They went from 0 to 40, and then 0 to 1200, it looks like, for their Y scale. So they did change that. Now B, we're going to plug in 16 for X, and then simplify. So when I plug 16 in for X, I get approximately 167 board feet. And then the last one, we're plugging 500 in for B, and then solving for X. And this one, you're going to have to get everything to one side. So they started by subtracting 500, and then they used the quadratic formula. Notice that we only want the positive value for the quadratic formula because it doesn't make sense to have a negative outcome for this. Okay, so that looks like using the quadratic formula, we would get about 26.6. And if you don't remember the quadratic formula, remember it's opposite b, plus or minus the square root of b squared, minus 4ac all over 2a. So in our case, we would have 1.32 plus or minus the square root of 1.32 squared. And technically it should be a negative 1.32 squared, but it'll give you positive. A is 0.77, and C is negative 509.31, all over 2 times 0.77. So when you simplify, you should get the 26.6.